Hello, everyone. This is episode 3 of our uh, rocket discussion.
Hi everyone. This is a content for the Chandrayaan 3 with the LBM 3 rocket. So today we will talk about Indian rocket this time. They launched July 2023, and their rover lander landed successfully August 23, 2023. The rover and the orbiter called the Chandrayaan 3, and the rocket is called LBM-3. LBM-3 means Launch Vehicle Mark 3. That rocket is a three-stage rocket, and the first stage is solid booster engine. When you see the rocket, you see the side two long bar. That's a solid engine rocket. You call the S 200 booster since we call use solid S 200 fuel. So the rocket diameter is 10 feet, and their empty weight is around 68,000 pounds. Their specific impulse is around 274.5 seconds. Second stage rocket is a liquid rocket, and it called L110. It has two Vikas engine. Vikas is Bakram, Ambalad, Sarabahi, and they have used two. That's a little bit uncommon. Normally they use the odd number of rocket engine, but LBM-3 has two. This rocket engine originally from France. It built by 1979 called Viking engine. The manufacturer of France is Safran. This engine has diameter is bigger than first stage engine, 13.1 feet, and their specific impulse also higher, 293 seconds. And their weight is, of course, is lighter than empty weight is 20,000 pounds. They so Viking engine model 5C is have a couple of components: nozzle, small pipe, small spear, gasket around the purple plate on the pump, and five equidistant bolt on the pump fixture, pump proper and multiple bolt on the top of a cylinder, the other side the engine and stand. So interesting is nozzle. Nozzle material is non-ferrous high resistance stainless steel. So that's general mechanical system, especially first and second stage rocket section. Victor, do you want to add more information about the mechanical system?
Not much on that, but the fuel that is used is hypergolic fuel, and the oxidizer is nitrogen tetroxide, and so the fuel is kind of like igniting directly by itself. So it's very how do you say, it's proven. It's a proven kind of fuel, so it will seldom not work. As in contrast to what the new rocket engines that SpaceX using the methane and oxygen, and what the SLS engine is using hydrogen and oxygen. So these
Yeah,
are the newer kind of fuel.
yeah. I think their LBM-3 and Chandrayaan-3 is from kind of a previous generation design, more robust and proven technology. That's why they use also 1970 Viking engine style. Okay, I will move to their electrical system. So we will talk about the electrical system of the rocket. we assume their rocket design is close to the current French rocket Ariane, and Ariane has a battery system, and we keep with power distribution and protection box. So they connected their electrical system with power distribution and protective box with one capacitor system. Their cell can generate 4.5 kilowatt per hour maximum, and they have 20 serial cell and two parallel strings. So total cell we according to spec is total 48. And one interesting thing is they have the heat problem on their cell, so they equip with limited summer gradient system. So from battery and power distribution and protection box, then they have your local system get the power. They have capacitor in there, and the string to the battery have some heat problem. So that's why they keep with the limited summer gradient system in there. And further in future, we will talking about a little bit more about how they generate or how they keep the electrical power from in the rocket. In the airplane, the airplane engine can work as a generator, and they have a kind of power circuit in there to protect all the electrical system. I believe rocket general aircraft to generate like 280 volt AC, and they converted around 28 DC. They use them on uh, through the aircraft system. So Victor, can you add more information about the rocket general electrical system?
I think you have it covered pretty well. So I don't have much to add on that. I think the second stage is I'll talk about the second stage is actually the hydrogen and oxygen. So it's powered by cryogenic engine on the upper stage. So that's a newer design.
A newer design.
Mm-hmm.
Okay.
And so I think Chandrayaan 3 took some lessons from Chandrayaan 2, which had a problem with landing. They did produce too much thrust for landing.
Oh.
And also some of the maybe the laser ranging system that could be related to what's happening from the in-twin machines, which they lost the capability for the laser ranging, and they have to use the Doppler LiDAR, which is the new system that has not been tested before.
Oh, okay.
So I think this Chandrayaan 2 had an orbiter that is still in use. They reused orbiter for Chandrayaan 3, so they saved some money not making a new orbiter. And yeah, so for the rocket, it was reliable because even Chandrayaan 2, they have a reliable launch, and they were basically rockets used for the geostationary orbit. And for the moon this time, they used the trajectory is a long trajectory, which is lasts for months, because they used the Earth's slingshot, so they have to circle around the Earth several times, and adding to the apogee, so more and more toward the moon until the last slingshot towards the moon. And toward the moon, because they have to land on the South Pole, they have to use the polar orbit. And but it was very successful for Chandrayaan 3. I think the only thing about it is that it didn't survive the 14 nights. And they cannot restart the second time, but maybe better electronics next time. Yeah, and they do have several accomplishments with the instruments there. They have the instruments called RAMBA, which is the radio and anatomy of the moonbound hypersensitive atmosphere. And the CHAST, which is the Chandra's Surface Thermal Physical Experiment, to measure the thermal properties of the lunar surface regions. The ILSA, which is the instrument for the lunar seismic activity, and also the LRA, which is the retroreflector array, and the last one is the LIPS, which is the laser-induced breakdown spectroscopy. Also an APXS, which is alpha particle spectrometer. And so they detected about different compositions for the moon: the magnesium, aluminum, silicon, potassium, calcium, titanium, and iron. So, and the rover traveled about 300 feet during the time when they have sunlight during the lunar daytime. And so they did a few things that is right, and also the ranging worked, and the thrust was not over thrusting this time like Chandrayaan 2. And the orbiter is doing fine. So they had a pretty successful landing. It's a fourth nation. India is the fourth nation to land after Russia, United States, and China. And then we know that Japan is the fifth one. The Japan agency JAXA, the commercial one, the Japanese commercial one did fail, and also the Israel has a parachute, which is also failed. The parachute has failed because of they have to reboot the system, and the system was in the states that is recorded in the volatile memory. So that when they reboot the system, all the volatile memory for the accumulated states all gone. So Israel says the lesson learned for Israel is that they have to make a new system that will survive a reboot.
Oh, that's a very good information. We should consider that software, hardware consideration for our design.
Yeah, and NASA has this advantage, a lot of advantages. They have the Deep Space Telescope in Goldstone, and also they can rely on all these different nations in the world, in Australia and in Europe, the Deep Space Telescopes. This time also Chandrayaan 3 has its own Indian-based Deep Space Telescope. So they rely on all these telescopes in the world to make sure there's no gap in the communication in between. Even also on the braking, the lunar insertion and the braking to braking the orbit and land on the moon. So the ranging, the laser ranging is okay, and also they use a stereoscopic camera system also for the determination of distance also. So they're using pretty cheap equipment. So, but those equipment and the software did work as planned.
Oh, that's so they use multiple sensor to landing in the good spot. you mentioned they land pretty close from their target, right?
Yeah, it's pretty close, and they are the first nation to land closest to the South Pole.
Oh, that's an interesting fact too.
Right, and
Yeah.
these Inter machines is landed on the Malaport A, which is also close to the South Pole. So every nation is trying to get to the South Pole to get the ice,
Yeah.
to drill the ice down there for the water.
Yeah, when we send our drill machine with some league water from Texas together, we have to probably clean areas a little bit. We have to remove all their lander. Yeah. So we are warning not many the land to other spot. You have to give us space for future. So you mentioned before our preparation. Your SLS 2 and 3 plan to send the drilling equipment, right? SLS 2 will be astronaut, and the
Yeah,
SLS
SLS-2, I think Artemis-2 will be crewed to go
2,
around
yeah.
the moon. I think it will
Oh,
be very similar to Apollo 8, which is around the moon. But Apollo 8's difference, there are a few differences. I think the main difference is that Apollo 8 just go around the equator orbit of the moon, and the Artemis 2 is going around the moon, but it's more like a polar orbit. It's more like a no, it's still a DRO, which is still close to Apollo. The Apollo project, and but Artemis 3, that would be starting to be different. That would be focusing on the polar orbit, which is closer to the because the South Pole, you need a polar orbit instead of the equator orbit. So it would be skilled, very skilled. It's more than 70 degrees from the more than 70 degrees inclination. If you do South Pole, it would be close to 90, closer to 90 degrees.
Oh,
It's perpendicular polar orbit. So Chandrayaan 3 has achieved as the first nation to succeed in landing in the closest to the South Pole first.
oh, that's good information about the SLS 2 and 3. So SLS 3 will land, right? Land on the moon, right?
Yeah. SS3, I think there was a change in the previous plan. The previous plan is to use a gateway, and so SS3 will not use the gateway. It will be just direct landing.
Direct landing, yeah.
Direct landing, and using the lunar lander that's designed by SpaceX, and we are very interested to see that SpaceX succeed in the test that they're going through right now. The last test that they tested was OFT2, and I think on return the tank exploded. So the first stage tank exploded. I think partly because of the sloshing pressurization, and so they have to do new designs on the baffle.
Oh, okay, I see.
The anti sloshing baffle. But basically the thing is that SpaceX has a large rocket, and it has to be reviewed many times, more than 10 times on orbit. So they have to test all these different maneuvers and also operations that's never done before. But basically, we'll be landing with Artemis 3. We'll be landing with the lunar lander designed by SpaceX. It's more like a little rocket than the Apollo. The Apollo has both the ascent stage and the lander. And with this lunar lander by SpaceX, it will be just like a little rocket that can actually do descending and also ascent. So it can do both ascending and descend. It doesn't need a separate lander and a separate ascent vehicle.
Yeah, it's a very sound, very good plan. At the same time, very ambitious.
Right, right. And
You
I think we have some the advantage for America is that we have the core software that is also been proven. We have the Apollo era core software. All this has been used all along. So America has the historical advantage
Yep.
on
Yeah,
the
we
on the
call
software.
what we call the intellectual property. We have
Right.
intellectual property, and
We
yeah, we
we are cooperation of the world, so it's I would think it's easier for us, yeah, instead of other nations that has to do, like China has to do their own deep space telescope deployment.
yeah, that's the current situation. Yeah, but I'm positive. Politically, China will be democratic nation, and Russia become more better country in the future. I know war is ongoing. It seems like kind of not just ideology. The Ukraine war is more like also historical. Some part of Ukraine is
Yeah, that makes me think about the Russian astronauts are still working very well with the Space Center astronauts
yeah,
and pretty good friends. Even the Russian chief, the science chief in for rocket science chief was uh, giving an atrocious statement about America. But I think politics aside, I think we're still scientists and engineers would be more friendly,
yeah.
and,
That's
and,
good.
and we'll be building new worlds together aside from the politics.
Yeah. Good point. Good point. Good point. We are for the humanity. Yeah. So any other content you wanna mention? Oh, the during preparation you mentioned a little bit about um, moon soil and possible structure we will build in the future. Can you mention a little bit about that information about certain finding about moon soil and how we can build our base?
Oh yeah,
Okay. So
you
as
know that the moon has interesting regolith that we can actually melt and then make into glossy forms and then build out systems. I think uh, also it has a natural vacuum. If we have to make a vacuum on Earth, it would take a lot of money and some equipment, at least heavy equipment that we cannot bring directly to the moon due to the cost. But on the moon, we can use the vacuum to make some electronics. For example, some vacuum tubes electronics, because it's naturally a vacuum, and then we can make the glass bricks out of the regolith. And what Chandrayaan discovered was that the thermal insulation is very good for lunar soil. They just stick in like the 10 centimeters, and they have already a big difference in temperature. So the insulation is good. So if we make something out of lunar soil, we may be able to make it less thick and insulate from the intense temperature difference, below minus 180 degrees Celsius in the lunar nights. But the not so good thing about the Chandrayaan-3 systems is that they didn't survive the lunar night, which is 14 nights.
yeah,
Every night is about minus 180 degrees Celsius and lower than that sometimes.
yeah.
Uh, So in that sense, I think the Japan, the JAXA one survived at least once.
Yeah, yeah,
They
yeah.
can restart. They can restart after the 14 lunar nights, and they actually put the battery state of charge at about 15%, and then they stop, put in safe mode to just stop everything that they're doing until they have the sunlight again. And they did it second. They can restart the engine. They can restart the system after 14 nights.
That's a good preparation and design by Japanese team. Yeah,
Yeah, we will learn more on the different lessons learned. Actually, for the Intuit machines that we saw just yesterday and today, that they have some mishaps on the ranging detection systems. They have the laser ranging system that didn't work, and they have to rely on the newest one that is not tested before, but it's a NASA-based LiDAR system, which is the Doppler LiDAR, but it worked the first time, so
that's good.
that saved the day for them, because they can
Yeah.
land, they can still range and land.
Yeah.
They did also one leg is obstructed and they have to land sideways, but
Yeah, they are in the sideway now.
but the
Yeah.
systems still work. And they rely on the LDN, which is proven in Optimus 1, the LDN network, and those help them, because they have did several things that is different from the other ones that they have turned the antenna 1, 2 to 3, 4 to track sunlight, and they have to recycle the software, the recycle these antennas for communications purpose. So they did several things that is safeguarding the mission.
Yeah, we call that one monkey patch. You know, you update the software during the runtime.
Yeah,
Yeah.
they did it very well. They were in orbit for longer, maybe 1 hour, 2 hours longer,
Yeah,
to do the patch work, to switch the not expected, unintended anomaly.
Yeah, but I'm glad even it isn't monkey patch is not good practice for software development. But I'm glad that they had we call the backup system, and they also had the software ready. So that's a good response to the team. And I'm aware Astrobotic actually try first as a private lander, but they failed it. So I believe intuitive machine get a lot more help.
Yeah,
from
I
now.
think the Peregrine was failed because of leakage. I think a fuel
Yeah.
leakage. Yes.
So I think NASA this time probably had kind of leadership role to help the intuitive machine to achieve first, first the private company to land. But yeah, we thanks for NASA for leading all the project and do many knowledge, accumulated knowledge is a lot of benefit from the Apollo and the space shuttle program. We will, yeah, for my future prediction is we probably not just Apollo bring back Apollo. My prediction is somebody will bring back space shuttle too. It's an amazing system. I live in California, Los Angeles, and we got the space shuttle. I think it was 5 years ago in our science center, and then now we got the booster and the main tank. So they lifting up space shuttle, and they putting the booster and the main tank outside. So
Yeah, you're lucky. You're lucky. You have the real thing there.
yeah, everything there. A lot of yeah.
Texas
lucky.
only have the mock-up.
Yeah, very lucky. Maybe because we have a nicer weather than Texas, and a lot more people. Very expensive here. Yeah, especially the uh, inflation. Recent inflation is kind of a lot. Okay, Victor. I think we cover most of the thing. Uh, we planned it, and it was a very uh, very technical rich episode. Oh, you mentioned also Chandrayaan used some antenna from other country. They got a lot of help. So can you list the country of so they can get the credit? India.
Yeah. I think they have help from the Deep Space Telescope, Goldstone in United States, America. They have it in Australia. They have it in Madrid, Spain.
Yes, very.
So different countries help out on the coverage of the signals because they cannot afford to lose any coverage. I think you have some loss of coverage when you're behind the moon. When typically when you fire the engine to break the lunar orbit and descend, you have to break it. Typically at the backside moon in the perigee, and so that's the moment where you lose some communication there, and everything has to be autonomous, which means that the software has to work by itself and without direct control from the ground. So you have to be good in doing autonomous. So your control algorithm has to be good for some of these moments. Yeah.
Yeah, that's a good. Yeah, thanks for all the help, especially from NASA and the EU. To India can achieve amazing thing. Yeah, in their technology and yeah, as we mentioned, Saffron helped the rocket engine and probably they learn a lot from the Ariane. Their design is quite similar from outside. Yes. So Victor, this is the end of episode 3. Episode 4. I remember you wanna do intuitive machine landing for the episode 4, right?
Yeah, I think it's a good one to look at into. They have a very kind of interesting landing, different kinds of issues and different kinds of how they overcome these issues would be very interesting to talk
Yeah,
about.
that will be great. So, thank you for everybody for watching episode 3, mostly for the Chandrayaan 3, LBM 3, the mechanical system, electrical system, and software, and also content related to the moon landing and moon future base, also upcoming SLS2 and SLS3, and also a lot help of Chandrayaan from other country. Also, Victor mentioned a little bit about intuitive machine current landing and status. They landed at February 2024. So it's a amazing time.
It's the first American. It's the NASA CLIPS program, which is more completely commercial, and it's after it's more than 50 something years.
57.
57 years after the Apollo program, and so we are very happy about its success.
Without all the intellectual knowledge from NASA and help, probably it won't happen in February 2024. And we are really exciting upcoming SLS3, SLS2. How many SLS is building right now? I know we launched SLS1 and we are making SLS2 and 3. How many more?
I think it's The plan is up to the plan is up to 15 or to 20 because it's future. It's a future planning for Mars. So
Yep.
after Artemis 11 or something, it will be a Mars mission. So everything we'll be learning will be from learning how to survive, how to work the soil and do infrastructure, and how to make energy, how to use the rovers, and how to dig up the ice and make use of the ice for the hydrogen and oxygen, how to make use of the soil to make the bricks, and for how to make electronics on the moon, and how to survive, how the doctors have surgery on the moon, right? For instance,
Yeah. That one is, how could I say? We have a fly surgeon. That one, how can I say? Space surgeon?
right, and then the way to live is either to live by the cave or do make some structures, 3D printed structures. Even the Inter Machines rocket engine is 3D printed. So we'll have to live off the land, so to speak, live off the land of the moon, and because the moon is only has a delay time of a few seconds instead of minutes when we're on Mars. So we have to practice a lot to survive. How do we make our first coffee on the moon? Right?
It will be fun.
Right.
Thank you for everything, and we will see you guys at the episode 4. And up to that time, have a wonderful days. And we are living in the second boom of space race. It's amazing. Okay.
Right. It's really amazing. Thank you so much.
Thank you. Bye.
Thank you. Bye bye.